Alright everybody, hello and welcome to the statistics class. I'm Dr. Amit Verma. Again, I'll make this short videos which will educate you about the chapters, and it's my take on the chapter. So I might pull some different examples than what is given in the slides, and again, you're not forced to watch these videos, but this might be helpful, and this might guide you through the entire course. So let's start with what is statistics. Again, the slides are available on Canvas. This is the chapter 1 slide, and this chapter is about introduction to statistics. So statistics is a way to get information from data. Now we might have different sources of data. We might have the data as a text file. We might have the data as an Excel sheet. If we are trying to get information from this data set, this is where statistics will help you. So statistics is a tool for creating new understanding. Now again, this understanding can be new decisions that you make. It can be the inferences that you make based on the data. So all this will comprise statistics. Let's look at an example. Let's say that we have a professor, and he wants to summarize his data set. So let's say, for example, the professor has the score of all his students in the class. So again, what is happening is this scores are out of 100. So this is student 1, he got 65 out of 100. The last student got 65 out of 100. So now we ask ourselves, what is the best way to summarize this data? If the professor is having a conversation with somebody else, he will not tell them all the marks that all the students got. The professor might be interested in some measures of central tendency. Okay, we'll talk about these measures in chapter 3. But this is a good way to summarize the data. So one nice way is the professor might come to you and say that the mean of my class is something. So let's say 72 point something. Or he can either say the median of the class is something. So that's like 75. So this is one way to summarize the data. So this is where statistics will help you. Or he can also visualize the data. So that's one aspect of it too. So he can make what is called a histogram. So he can also go and say that, okay, in my class there are 15 students who fall within 70 to 80 marks, okay, who have between 70 to 80 marks, and there are only 5 students who have 80 to 90 marks, and then there are only 2 students who have 90 to 100 marks. So he might show you this visualization. So this method is called the numerical techniques. So this is a numerical technique, and this is a graphical way to summarize the data. So if you look at the slides, one way to summarize the data is using the mean or median, and now this information might not be sufficient. So this is a measure of central tendency. We'll talk about that in chapter 3. So what might be sufficient in this regard is knowing the mean and median will not always be sufficient, because there might be 2 distributions. So like, let's say one distribution is like this. This is the mean of the first distribution. Another distribution is having the same mean, but it's more spread out. It's more like that. Okay. So again, knowing only the mean and median will not be enough in some scenarios. We should also know what is the range of the data, or what is the spread of the data. Okay. So this quantity is called the range. We'll formally define these quantities in the coming classes. So range is one thing that you might be interested in. This will tell you what is the spread of the data. Now These techniques, mean, median, mode, and range, are numerical techniques. We are trying to find a number that describes the data. Now you might also be interested in visually describing the data. So there are multiple ways of doing that. One is a histogram. So histogram provides a capability of dividing data into bins. So if the spread of the class is something like this, and again I have talked about this example, that means there are 10 students between 70 and 80, between 90 and 100 there are only 3 students, and so on. So this is also useful because if you know this kind of spread, and again you can look at this course and look at how do I calculate your grades. So your grades are calculated like this. If you have between 90 to 100%, you get an A. If you have between 80 to 90%, you get a B. 70 to 80%, you get a C, and so on. So for me, to find out these grades, it's very good to visualize this data, and histogram is one of the important tools that I can use. So let's look at a spread. So this means that this is one sample histogram, and this means that so this will tell you the frequency or the number of students who fall in that category. So this is one bin, and again we'll formally define this concepts in the coming chapters, but this is introduction to statistics. So this is a bin, so it will define how many students belong to that category. So how many students are having 65 to 75, between 65 and 75 marks. So these are 20 students, so this is 20. So all these categories of describing the data, and now if you are able to describe the data with a number or a graph or some kind of tool, it will help you to talk to other people about statistics, and this kind of techniques are called descriptive statistics. Again, descriptive means they are trying to describe the data. There's a second category that we'll look in this class, which is called inferential statistics. So again, this inferential statistics is about making decisions or inferences based on data. So let's say you know the sales for year 1, year 2, year 3. Let's say you have the sales of Coke products as 150,000 and 200,000 and 300,000. Using this historical data, now this is the historical data. Using this historical data, can you predict or infer what will be the sales of Coke products in year 4? And this is where inferential statistics will help you. Now the way you set up an experiment in inferential statistics is by using a sample from a big population. Okay, so usually let's say you want to conduct a survey among all the students in this campus, finding let's say the parameter of interest is what is the proportion of smokers in the campus. So to establish this quantity, this is the quantity of interest, and again your population is the total number of students that you have in campus. So this is for the entire college. Okay, so let's say you have 50,000 students in the university. So this is this big group of 50,000 students. 50,000 students. Now I don't have the resources to survey each of these 50,000 students in the campus and ask them whether they smoke or not. What I might do, so this is called your population. What I might do is pick a small sample from this population. So this is your sample, and this sample will be manageable. So this sample will be, let's say, of 100 students. And now what I will do is I will conduct the survey among these 100 students, and if I, let's say, find that 75% of them smoke, using this data from the sample, I will make predictions based on the entire population. So if I only have this information, I will conclude that 75% people of smoke in the campus. Again, this might not be correct, but this is the best we could do. So these kind of techniques are covered in inferential statistics, and we talked about two different things. We talked about population. It's a group of all items of interest. Now this might be all students in the campus. Again, but surveying this entire group might not be manageable, so you choose a sample out of it, and this sample is where you perform all your experiments. Now if the quantity of interest is associated with this population, so here percentage of smokers, let's say, that's your quantity of interest. If the quantity of interest is associated with population, it's called the parameter. If it is associated with the sample, it's called the statistic. So again, different fancy names, but both of them convey the same thing. So we will use the statistic to make predictions or infer. So we'll use the statistics to infer about the parameter. Okay, and we'll talk about the details moving on. And this is one graphical way of describing what I just said. So populations have parameters, samples have statistics, and we'll talk about these methods in the coming classes. Chapter 2 we'll talk about graphical techniques, and this will be the next video. We'll talk about the bar graph, histogram, and in chapter 3 we'll talk about the numerical techniques, so mean, median, mode. So I will see you in the next class, or in the next video, or should I say, and we'll talk about these techniques in detail. Okay, bye.